Welcome back to the Greater Essex County District School Board calendar, where we are exploring the fundamentals of mathematics. Each month, we are diving into a big idea from the Ministry of Education's Focusing on the Fundamentals of Math, a Teacher's Guide, and in particular, the table summarizing curriculum expectations from our current Ontario mathematics curriculum that have always been and will continue to be fundamental for developing students' understanding and proficiency in mathematics. Over the next few videos, we'll explore developing mental math skills in order to work towards mastering math facts. Let's begin by exploring the first operation students encounter, and at quite an early age. Addition. In particular, we'll be exploring addition structures or types of addition, as well as properties of addition. Let's get started. Now, with addition, we have two structures or ways we can think of addition scenarios. The first is pretty typical. Suppose there are 3 chicks eating. Then 4 more chicks come to eat as well. How many chicks are there altogether? Now, this is a pretty common scenario, and it has a name. We call this a joining addition problem, and some even call it active addition, since some action took place here with the second set or group of chicks that came into the scene after. Now let's look at another addition structure. Here we have Landon, who has 4 loonies, and Talia, who has 5 loonies. The question is, how many loonies do they have altogether? For you and I, it's likely that we don't see this type of addition differently than the first. However, there is a slight nuance, and that is the fact that there was no action. Here, we're given 2 parts, and we're hoping to find the whole. We call this part-whole addition, or passive addition. Something worth noticing is that both addition structures, joining or active addition, and part-whole, or what we call passive addition, look pretty similar when we model with the visuals on the screen. So it's probably not necessary for our students or our children to be able to identify the structures of addition, but we do want to ensure that they can recognize both types of scenarios are in fact addition. Now, let's look at a really important number property that applies to addition, regardless of the structure. I'm sure you'd agree that 4 loonies plus 5 loonies is equivalent to 5 loonies plus 4 loonies, right? Well, our ability to move or swap the addends in an addition scenario is known as the commutative property. Now, the name sounds pretty scary, but think of the word commute. Some of us commute to work each day or commute to the soccer field. Well, in addition, the addends can commute. Just like the 4 loonies and 5 loonies in this problem can commute. And the result is the same quantity of 9 loonies. And the same is true when we have more than 2 addends or 2 parts. For example, if we add Kiera, who has 2 loonies, we can commute the quantities of 4 loonies, 5 loonies, and 2 loonies in any order, and will still result in the same quantity of 11 loonies. 2 more loonies than we had originally with Talia and Landon alone. Now, you might be wondering, why does any of this matter anyway? Well, the commutative property is extremely helpful for us to build number flexibility with addition, and you'll see in later videos with multiplication as well. Here's what we mean. Let's go back to the scenario with Landon, Talia, and Kiera. By being able to commute the addends, I can more easily add 2 of the parts that are easier for me to do in my head. For example, some people like to take care of larger parts first and then deal with smaller parts later. Like in this case, starting with 5 loonies and then adding the next largest part, in this case 4 loonies. We can then add those 2 parts to get 9 and then add on the last 2 loonies later. But if we consider another property of addition we know as the associative property, we can break down or decompose a part, like taking 2 loonies and breaking it down into 1 loonie plus 1 loonie. And then we can reassociate the 1 loonie with the 4 loonie part in order to create another part or group of 5 loonies. For many of us, especially young children, adding 5s is much easier than adding 5 and 4. And guess what? We still end up in the same spot with a total of 11 loonies. I don't know about you, but when I was in school, I remember having to know what both of these properties were called, but I never really knew why they mattered or when I might try to use them. Hopefully, from this example, you can see how helpful this can be for students to build their flexibility when working with numbers, both early on in small quantities and then later on with larger quantities. Let's have a look when working with larger, less friendly quantities, how these properties can be helpful. Here we have 44 plus 53 plus 67. So while you or I could go ahead and stack these quantities and use the algorithm we learned in school for adding 2-digit numbers, doing a bunch of carrying, maybe even making a mistake along the way, why not try to apply our understanding of the commutative and associative properties to potentially add these quantities mentally? Let's first make a copy of this line to start with. What if we were able to decompose the numbers 53 and 67 into 50 plus 3 and 60 plus 7? The brackets I'm using for 50 plus 3 and another set of brackets for 60 plus 7 are suggesting that those addends are associated. Because addition is associative, we can break that association and use the commutative property to move the addend of 3 and the addend of 60 in order to reassociate the addends of 3 and 7. Now, why would we want to reassociate 3 and 7? Well, I know that 3 plus 7 is equivalent to 10, and I'm really good at adding 10 to any number. Next, I could commute the 50 and the 60 addends in order to reassociate 44 and 60, since I know 4 tens plus 6 tens is 10 tens, or 100, plus another 4. And 50 plus 10 is 60. I'm also pretty good at adding 10 tens or 100 plus any number. So 10 tens plus 6 tens or 100 plus 60 is 160. And let's not forget about the extra 4 ones that have been patiently waiting for us so they can be included in as well. This video was intended to just scratch the surface of some of the ways we can help our students develop mental math skills for mastery with addition. I hope you enjoyed this, the 6th video in our Fundamentals of Mathematics video series. We'll see you in the next part where we'll move from developing mental math skills with addition to subtraction. See you then.